So as you can see by the title of the talk, I won't talk so much about transparency today, actually, but I'm going to be sharing with you some of our work on auditing proprietary computer vision tools as well as data sets for fairness issues, actually. But before we get into that, I just wanted to take about a minute or so to tell you a little bit about the context in which my team and I are working, because it's always interesting how your context, I think, shapes what you end up doing. So I'm based at the Open University of Cyprus. It's one of 3 public universities that we have here in Cyprus, and it's actually the only one which is fully dedicated to open and distance education. And we're very passionate about providing non-traditional educational opportunities to the public, and more generally in promoting a culture of lifelong learning. And the reason that I wanted to say that is because I'll come back around to it at the end of the talk, because of course, it turns out that educating the broader public, not only people who work in technology, but yes, the broader public is extremely important if we want to promote transparency and fairness in AI. So we established the CICAT, the Cyprus Center for Algorithmic Transparency, back in 2018 on the occasion of winning a Horizon 2020 grant and collaborating with universities in the UK, Israel, and Italy, as you can see on the slide. And as I'm sure that you're all very well aware, there are many recent projects in Europe and initiatives that address various aspects of fairness and transparency in AI and machine learning. But I would say that what has differentiated our project from other initiatives is that in addition to conducting fairness and transparency research, we've also looked into ways of educating different groups of people, including both developers as well as non-technical persons such as public school teachers and the public at large. I also spend time at Science Research Center of Excellence, which is also based here in Nicosia, Cyprus. And Science focuses on applied research in the very broad area of interactive media, with a big emphasis on industry engagement and helping to foster the startup ecosystem here in Cyprus. So it's really in this context that my colleagues and I got inspired to undertake the research that I'll be sharing with you today, which looks at social bias in proprietary computer vision tools, which of course are often adopted by individual developers, typically, or a lot of times I should say, young people who are just getting started, small startups, and even those who of course don't really have much expertise or background in machine learning. So let's start off with some examples. I'm sure that you're all very well aware of this unfortunate incident, which came to light back in 2015 involving the Google Photos app. So a user uploaded his photo to the app, and its algorithmic tagger described him and his friend as gorillas. So Google, of course, apologized, promised to deliver a solution to the problem. But in 2018, Google announced the fix, which was simply to remove the offending word and other semantically related words from the database of the image tagging algorithm. And unfortunately, these types of incidents don't seem to be going away. This is one which came to light more recently, I believe this past September, involving the recommender engine of Facebook. And I use these examples, of course, not to pick on the giants of social media, well, and the tech industry more generally, but of course to illustrate how challenging it is to tackle problems of social bias in AI. The Gender Shades project out of MIT provided concrete evidence that indeed we have a lot of problems with computer vision applications when they handle images of people. And specifically, Lamouini and Gebru showed that commercial gender classification algorithms have a much higher error rate on images of people of color, and in particular women of color, who are of course often underrepresented in training data sets. And then in June of 2020, there was a very interesting development when IBM announced that due to the inherent challenges of social bias, that it would stop offering its facial recognition software for applications involving any kind of mass surveillance or racial profiling. Okay, so we know that gender recognition and face recognition tools are very problematic, but what about the more generalized computer vision tools like image tagging algorithms? So more and more often, these services are being offered as cognitive services or AI as a service. They take an input image and infer what is depicted, outputting a set of descriptive tags. And it's of course becoming increasingly easy and inexpensive for developers to use pre-trained models from some of the biggest names in the industry. These services have also been described as quote unquote democratizing AI and fueling innovation, as of course it's no longer necessary to have in-house AI or machine learning expertise in order to build these cognitive capabilities into one's applications and solutions. And of course, we should note here as well that it's not only developers who are using them, we increasingly observe that they're being adopted by the advertising and marketing industry, as well as researchers who want to study web and social media behaviors on a very large scale. In our research, we've been working with the 6 services that you see here. Of course, 4 of these are offered by tech industry giants, companies that offer a wide range of different cognitive services. And we also have Clarify and Imaga, which are startups that specialize in vision-based cognitive services. So there are 2 key research questions that we'll examine in this talk. The first one is, what are the behaviors of algorithmic image taggers when describing people-related images? You might hear me referring to the social behaviors of algorithmic image taggers. And then we'll go back to the issue of the training data and ask, what are the behaviors of crowd workers when they are asked to describe the very same people-related images? Of course, at the heart of this work is the issue of fairness. So in other words, we want to assess the extent to which taggers and also crowd workers treat the people who are depicted in these images fairly. So to this end, in this work, we rely on the notion of group fairness, which holds that people from different protected classes, such as race and gender, should not experience significantly different treatment as compared to the majority or the population as a whole. And recently, we've also been looking into the question of temporal change, both in the behaviors of algorithmic taggers as well as in people, as well as by crowd workers. So we'd like to believe, of course, that things are improving over time because there's growing sensitivity that we really need to ensure that AI applications treat people fairly. And as I'll be explaining, we've been in the process of going back and replicating studies that we originally conducted starting back in 2018. So I'll be able to update you a bit on how we've observed behaviors to change at 2 different points in time. So I'll compare 2018 versus 2021. So let me give you a roadmap for the rest of the talk. First, I will present the methodology that we developed in order to systematically study the behaviors of image tagging algorithms as well as crowd workers when describing an image of a person. And then I'll provide you with an overview of some of our most interesting findings. And finally, we'll discuss some of the implications of this work, as well as some concrete ideas for mitigating social bias in image data sets that require human annotations. Okay, in 2019, we published our first paper at ICWSM on our methodology for auditing the behaviors of the taggers as well as the workers. Yeah, so it was originally 2019, and then this June at ICWSM 2022, we are going to present the replication of our first studies. Given that image tagging algorithms, the ones that we're investigating, are proprietary tools, we needed an auditing approach that is, of course, appropriate for studying the behaviors of the black box process. And therefore, we aim to use 2 different auditing methods within platform audits to discover how outputs may differ for certain categories of inputs in one system, and also cross-platform audits to discover how all outputs of one system may differ from outputs of other systems for the very same input. We wanted to detect for any systematic differences in the descriptions of images as a function of the depicted person's gender and race. So we used the Chicago Face database, which contains 597 high-resolution passport-style photographs of people. The good thing about this data set is that, well, as you can see, it's highly standardized, and each individual's gender and race is self-reported, but it must be noted that gender is treated strictly as a binary construct in this data set, and in addition, there's no notion of being biracial or multiracial. So the pictured individuals have to report as being a man or a woman, and one of 4 races: Asian, Latino, Black, or white. To collect the algorithmic descriptions, we simply feed each CFD image into the tagging APIs, and we executed this process for the first time in winter of 2018 and again in summer of 2021. And we collected human-generated descriptions on the same images by using the Figure 8 platform, which of course has since been renamed Open. I'll provide more information about the task setup in just a few slides from now. We have 2 sets of human-generated descriptions from crowd workers, one from workers who are located in India and the other from workers located in the United States. Time-wise again, the first time that we executed the crowd experiments was in winter of 2018, and we replicated the process 18 months later in 2020. So here is an example of the algorithmic descriptions on an image from the CFD of a Black woman. So this is image BF231 in the data set. And just having a quick glance at this, we can see that there are many interesting differences between the tagger behaviors. So some of these descriptions are quite short, some are relatively long. We see, of course, that some of the taggers use gender-related tags erroneously. And also, we observe that some taggers, such as Clarify and Imaga, they get rather subjective in their descriptions of the depicted person. Excuse me. Because the taggers and, of course, the crowd workers use different vocabularies, we needed to identify tags with similar meaning or purpose. So we conducted a manual analysis of tags to identify those with similar meaning or purpose, and this led to the discovery of 20 themes, or what we call subclusters, which were further grouped into 5 larger clusters or superclusters. The resulting typology is the one that you see on the slide. So we have the 5 superclusters of tags. We have our demographic tags, which describe a person's gender, age, or race. We have our cluster of concrete tags, which describe attributes such as hair or clothing. In other words, they're attributes for which there is direct visual evidence in the input image. The third cluster is a very interesting cluster because it's our abstract tags. So in contrast to the concrete tags, these are tags for which there is arguably no direct visual evidence. They're very inferential. So we have judgment tags. These usually refer to a person's physical attractiveness. We have attributes that infer a person's character traits, their emotions, and even their occupation. The fourth cluster is other. Most of these are ambiguous tags. And the fifth cluster is our cluster of inflammatory tags. Fortunately, we don't need this cluster when we're studying the behavior of the taggers, but unfortunately, we do need them when we are studying the crowd workers' behaviors. Okay, so what changed from 2018 to 2021? And did we need to update our typology? So first, we found that we were able to analyze the tags collected in 2021 with our existing typology. So we didn't end up having to modify that. However, as mentioned, the IBM service was actually discontinued in 2021. So of course, it isn't analyzed in our replication study. The table that you see here uses our typology to compare the taggers' observed vocabularies across all CFD images, which we found in 2018 versus 2021. These shaded boxes are where we observed temporal changes. So right away we observe, of course, that the Microsoft tagger is the one for which there were very few changes over time. And as we know, the demographic tags can be very sensitive, particularly depending on the context in which the tagger is going to be used. In early 2020, Google announced that its vision service would stop using gender tags, and that's why you see the column of zeros for 2021 for Google. Another interesting observation is that the only tagger for which we observe the use of a tag related to race is the clarify tagger, and it's a multicultural tag. So to more easily analyze and compare the image descriptions by algorithmic taggers or by crowd workers, we represent each description as a vector. So we just calculate the proportion of tags in a description that map on to each of our subclusters. And then the vector representations aid us in comparing the image descriptions, either across different sources, one tagger versus the other, or a given tagger versus the crowd workers. So on this slide, I have a few examples of the kinds of sort of quick and dirty high-level comparisons that we can make. In these examples, we're using the average pairwise cosine distance to compare the descriptions over all images in the CFD. So on the left, we're comparing between taggers, and we can see that in particular, Amazon and Google are rather similar to one another, and IBM Watson, this is in 2018, is also not so different from these two taggers. In the table on the bottom left corner of the slide, we compared the 2018 data of each tagger to its 2021 data, confirming that Amazon and Clarify exhibited the most change over time. And on the right side of the slide, we see a comparison between each tagger and our crowd-generated descriptions. Here we have broken out the crowd data by the country of the crowd worker, so India or US, as well as the gender of the person depicted in the image. So there are some interesting observations here. For example, in considering the clarify tagger, its descriptions are closer to those of the crowd workers on images depicting women versus men, and this is true both when we compare clarify to the India or the US-based workers. I think we need to look more into this. Okay, having gone over our methodology, let's move on to seeing some of our findings concerning the tagger's behaviors when describing images of people. So getting back to the issue of fairness, there are many sensitive concepts in the tagger output that we have considered in our analyses. Some issues that we've considered in our work are the use of gender-related tags, the use of tags that judge a person's physical attractiveness, and even the use of tags that convey a sense of humanness. In these studies, what we're trying to ascertain is whether there's a systematic correlation between the use of such sensitive tags and the depicted person's race or gender. In our ICWSM studies, we reported on the use of gender-related tags by conducting a between tagger and within tagger examination, by conducting both between tagger and within tagger examinations. So we assume that, again, these are general purpose taggers, so we assume that a tagger inferred a person to be a man if it used more masculine than feminine tags in its description and vice versa. So in the between tagger audit, we compared their precision, recall, and F measure in recognizing gender. So overall, there is evidence that they misgender women more so than men. And of the 4 taggers that used gender tags in 2021, that we're still using them in 2021, I should say, we can say that Clarify had the most balanced performance. So this was true in our 2018 as well as the 2021 study. And it improved its tagging of women's images over time without degrading the performance on images of men. In the within tagger audit, we use a logic model to examine the accuracy on gender inference as a function of the depicted person's race. And we found at both points in time that for 2 taggers, the likelihood of using tags appropriately is lower for images of Black individuals as compared to the other racial groups. And of course, these results are parallel to those of others. Excuse me, I seem to have a tickle in my throat. Okay. In a study that we presented at CSCW 2020, we studied the role of the background context in taggers' gender inferences. So we systematically manipulated the backgrounds of the CSD images using 8 gender stereotyped backgrounds, including, for example, a wedding dress shop as a stereotypically feminine background and a mechanics shop. Excuse me. A mechanic shop, of course, as a stereotypical example of a masculine background. So using our methodology, we evaluated the accuracy of the taggers in recognizing the gender of individuals when placed into these 8 contexts. And we also examined how the descriptions of a given individual changed when a gender stereotyped context is introduced. Okay, in the interest of time, I will just briefly tell you about some of the more interesting results. So we found that most image tagging algorithms, quote unquote, saw more men or women in stereotypically gendered contexts as compared to the baseline images without a context. So they used a different ratio of masculine to feminine tags on a person's image when a context was added, regardless of whether this inference was actually correct. And we also considered the extent to which the description of the person image changed once it was placed into a context. And we found that the descriptions of images depicting some social groups changed more than others once they were placed into context. Specifically, those depicting women, Black, and/or Asian people changed more than the descriptions of white men.
Question.
Yes?
Would it not, in general, make more sense to remove background in any case? There are clipping magic, there are tools that remove background, like clipping magic.
The original images are without a context. So sorry, I think maybe I didn't understand your question.
Question is, does it not make sense to remove background regardless of what you're trying to do?
Well, I think the point is that the CFD images are artificial in a sense that they're not characteristics of the types of images that people are typically posting on social media, which are typically in some kind of social context.
Yeah, but there are applications like clipping magic which remove background. So before we do any classification, we just remove background.
Oh, I see what you're saying. So actually, when we are using these taggers, we could remove the background and then infer the person's gender. Is that what you mean?
Yes.
Actually, if our results would actually suggest, though, so our results suggest that the taggers are more accurate when there is a background.
But there's also bias.
Yeah, that's true. That's true. So we had a look, for example, at sorry, this tick in my throat has really gotten to me today. We had a look at how accurate they are in isolation, how accurate they are when there is a background, but the tagger has not recognized the background properly, and the gender recognition accuracy when the tagger has when there's an indication that the tagger has recognized the background properly, because there are descriptive words there suggesting that it has understood it correctly. And that's the scenario in which the tagger is most accurate on getting the person's gender as well. You're absolutely right that there's social bias there, but the world is biased as well, of course. And again, take into consideration that we have, as I mentioned before, these are images of people who have identified as being women or men. We don't have any examples in this data set of people who are non-binary. Sorry, I don't know if I answered your question.
That's okay. Thank you Thank you.
Sure, you can come back to it, sure. Okay. A colleague of ours here in Cyprus, Maria Matsangidou, used our methodology to study what she called algorithmic attractiveness. So many of the taggers, of course, use words such as those shown on the right-hand side of the screen, which relate to or even judge a person's physical attractiveness. So the analysis has two key findings, one of which is that the more inferential taggers, which again are Clarify and Imaga, do use such tags when describing images. They use them more when describing images of women versus men. And in addition, Asian women in particular tend to receive more attractiveness tags as compared to the other 7 demographic groups. The Chicago Face database also provides some measures on attributes, such as attractive and baby face, which were collected by its creators, who are social psychologists. So in short, Maria's analysis provided evidence that what taggers find attractive is correlated to what people find attractive. Finally, we've studied the tags that ITAs use to describe the presence of a human in the image, and we looked at the potential of the taggers to dehumanize people. The first step, of course, was to identify the vocabulary that the taggers use to indicate the presence of a person. So as you can see, all of them use a person tag, although Clarify actually uses a no person tag. Watson had 3 textually overlapping tags, but the analysis shows that these tags are used in distinct manners. So findings indicate that the humanness concepts, such as human, person, and people, might be completely separate for some ITAs. And another pertinent question is, of course, the issue of error and the question of whether certain social groups are missing the humanness tag as compared to others. We grouped the outputs by the depicted person's race and gender, and it does appear that higher proportions of women, and in particular Black women, had their images receive no humanness tags at all as compared to the other social groups. Okay, so now let me share with you some of the findings on the behaviors of our crowd workers. And I promised to give you more details about the task presented to, that we presented to crowd workers on APIN or Figure 8 back in 2018. So in the task, workers were asked to quote unquote, help us determine the content in the images we provide. And after being given the rules as well as an example, they were prompted to provide 10 descriptive word tags or 2 word phrases of their choice, of course. And finally, they were asked to provide their own gender and race. So why did we go with this open-ended annotation task? So we found that it's surprisingly difficult many times to find details about what workers are asked to do when annotating images that are intended for a computer vision training data set. So we can take, for an example, the celeb faces attributes data set, which is a popular data set on Kaggle. It's intended for training models to recognize facial attributes, and it contains 40 manually annotated binary attributes, such as whether or not someone has a 5 o'clock shadow, is attractive, is bald, so on and so forth. But we can glean no information about how the images were annotated or by whom, what exactly were the instructions. And it's a bit worrying because we can see that many of these attributes are rather subjective. Furthermore, over the past few years, computer vision researchers have cited reporting biases in human-generated labels in their training data. So they've argued that so-called human-centric annotations on images contain a wealth of information beyond strictly the content of the image. So in other words, human-centric annotations tell us what's worth reporting in an image and not strictly what is in the image. The major data sets for developing computer vision algorithms are, of course, heavily reliant on crowd work and thus represent human-centric data sets. However, arguably, their creators intended for workers to focus on content. So these are 2 quotes from older papers, but I think they're quite interesting. For instance, the creators of Flickr 8K claim to have obtained conceptual descriptions that focus only on the information that can be obtained from the image alone, Likewise, MS Coco creators asked MTurk workers to describe all the important parts of the scene. But there's a good deal of literature, primarily from social psychology, that underscores the idea that people's inferences about others would make their way into the natural language descriptions of people images. In other words, when workers are asked to use their own words. So let's finally see what our crowd workers said about the CFD images. In work that we presented at HComp a couple years back, we conducted an analysis on the workers' use of the more sensitive tags in our typology. So the demographic tags are probably pretty self-explanatory. Shape is a tag that is a set of tags that, while in our cluster of concrete tags, it's interesting because it could relate to the shape of the eyes or the face, such as a round face or almond eyes. In the abstract tags, the judgment tags primarily have to do with perceived physical attractiveness of a person, as we saw. And finally, we have the inferred character traits of the depicted person and also his or her emotional state. So for each type of tag, we fit a logit model with mixed effects to predict the event that a description used at least one such sensitive tag. The explanatory variables were the demographic group, so the race and gender combination of the depicted individual, and we also included a control variable for the location of the worker, so US versus India. And we found significant differences between the descriptions of the India-based versus US-based workers in terms of their use of the sensitive tags. Through post-hoc tests, we examined which demographic groups of depicted persons truly differed from one another, and this showed that images of Asian women were less likely than others to be described with gender and age-related tags, but more likely to be described using shape-related tags. As I mentioned, there were references, for example, to almond eyes. A lot of describing the shape of the eyes. Images of Asian men and women, as well as those depicting Black men, were more likely than other groups to be described using race-related tags. Social psychology theories of linguistic bias predict that we tend to use more abstract language, so making inferences about someone without necessarily having concrete evidence, when describing people who belong to our in-group. So here we examine how white men and women workers based in the US treat images of their in-group members. So the figure on the left shows the proportion of descriptions by white women that contain at least one abstract tag by the demographic group of the depicted persons, which are represented by the different colored lines. So we actually don't observe separation of the lines. We don't observe significant differences between the different groups. In contrast, we do find something interesting in the descriptions that were provided by the white men. So specifically in the right side figure, we observed that over the set of 10 tags, more than 70% of descriptions by white men about white women contain at least one abstract tag, which is significantly more than for the other demographic groups. And finally, this is the last set of results. I'd like to tell you about work that we presented at last year's ACM Chi. So in a nutshell, we replicated our annotation task at APEN, collecting data from US-based crowd workers during May and June of 2020, during the unprecedented events of the COVID-19 pandemic, but also during a time of significant social unrest due to racial discrimination in the US. So we hypothesized that with the significant impact of these factors on people's lives and the extensive media coverage of the Black Lives Matter movement, as well as COVID, that concepts of health and identity would be at the forefront of our workers' thoughts. And so we wanted to investigate empirically how data collected in spring of 2020 would compare to that we collected 18 months previously. So we needed to update and enrich our typology of tags to focus on the topics of the inferred health status and identity of the depicted persons. So as you can see on the slide, we not only have the race subcluster within identity, but we also have tags referring to external features, skin color and what have you, which correlate to identity, as well as their inferred nationality. And then within the health cluster, we separate tags describing symptoms and overall inferred health status from those that describe a person's weight. So just to describe briefly some of the interesting results, with respect to the tags relating to identity, we observed more race-related tags in 2020 versus 2018, but only for images depicting Black individuals. And in addition, we observed a greater tendency in 2020 for workers to infer the nationality of the depicted person using tags such as American or US citizen. So while we did not observe any increase in the use of tags related to a person's overall health status or particular symptoms, we did find an increased use of tags related to the concept of being overweight. And of course, in a similar vein, we know that Google Trends for web search terms during the same period of time had demonstrated a spike in terms such as healthy recipes or quarantine workout. So while we cannot claim, of course, a causal link here, it seems very plausible that what people are currently experiencing in their lives tends to be reflected in their digital traces. And of course, crowd work is no exception here. So we should keep in mind that during stressful times, workers' responses on an open-ended task like ours reflect what is affecting them and what is on their minds. What to make of all this? As we all know, data is one of the critical infrastructures needed to develop AI systems, but paradoxically, data work is arguably the most undervalued and de-glamorized aspect of AI. And I'm quoting here, of course, from Simvasivan and colleagues who took the Best Paper Award at last year's CHI for their paper on data cascades in high-stakes applications of AI. And unfortunately, as they tell us, everyone wants to do the model work, but no one wants to do the data work. And this is, of course, a very big problem in terms of building responsible and trustworthy systems that also take social bias into account. In this talk, we saw that data, particularly in data sets where crowd workers are asked to augment or describe people-related media, depends on our perspective. And I'm sure that many, if not most, of the results that I presented today did not shock you at all. And many of the workers' behaviors were, of course, exactly as what would be predicted by social psychology theories of person perception and in particular social stereotyping. Still, some parameters in a crowd task can be controlled by the requester or the researcher in order to mitigate some of these effects. For instance, we can consider the worker-subject relation. So do they belong in the same demographic groups or not? Another parameter concerns whether the annotation task is open or closed-ended. So I only reported on research involving open-ended tasks today, but there's a lot of evidence that such tasks where workers provide natural language responses are more subject to social bias, such as stereotyping. And even a simple parameter like task length can also correlate to the expression of biases in the resulting data. So in our HComp paper, we explained that race marking typically happened early on in a task. Race tags, in other words, were given right away by workers. However, abstract tags such as attractiveness tags occur later on. So like in the 9th or 10th tag that a worker would provide, when they probably have to get more creative because we're requiring them to give us 10 tags. Finally, we have the issue of time and temporal sensitivity. So we need to be aware of the context and circumstances happening at the time of data collection. And the most important point is that dataset creators must carefully document all of the choices that they've made along the way so that this will help ensure responsible use and reuse of training datasets. Okay, just a couple of concluding remarks. In the context of our SciCat project, we conducted a systematic literature review of the empirical research conducted across different areas of computer science on mitigating algorithmic bias in a particular system or process. So in other words, these were the papers that we reviewed. It's a corpus of about 250 papers. They describe practical solutions, not philosophical or legal issues. And what we tried to do in our survey is to provide a high-level overview of the problems, solutions, and stakeholders that are involved in mitigating algorithmic bias. And in this figure, we depict the architecture of a typical machine learning process, indicating the components where problems can occur and/or be detected. We also see the various solutions for the detection of bias through auditing or discrimination discovery, fairness management, as well as explainability management. And of course, the types of solutions that we find discussed in the literature depend on the particular problem being addressed, but also the stakeholders involved and the degree to which they have access to the interworkings of the system. In the case of the research that I presented today on auditing proprietary computer vision tools to understand their social behaviors, we were in the role of the user rather than the developer. And since we did not have access to what goes inside of these black boxes, we used auditing to study the relationship between the inputs and outputs of the systems that we studied. Another way of looking at this work is that it benchmarks machine behaviors against human norms of fairness. And in contrast, in the studies that I presented concerning data bias, we could be said to be in the role of the developer who's going through the process of creating annotated training data. So in particular, we asked crowd workers to augment an existing image data set, and we studied the social biases presented in their descriptions. So from an academic perspective, it's very interesting to study the behaviors of algorithmic processes in humans, but how do we use such research to actually make things better? I mentioned at the beginning of the talk that it would come back around to the topic of education, because truly it has to be a part of any comprehensive solution to promoting fairness in AI. As I mentioned, one target group that we are working with are developers, so people with a technical background, but not necessarily a background in machine learning and AI. And we know, of course, that developers and startups are, in a sense, facing a bit of pressure given the hype surrounding AI, and that they can often command more funding if they align themselves somehow with AI and incorporate it into the products and services that they are developing. So here in Cyprus, we've started working with local universities either to offer standalone seminars on ethical issues or to help instructors incorporate some of these issues into their courses. And they typically do this in the context of the software engineering curriculum. It's often interesting to see how surprised some of the students are when we discuss with some of them our own findings and try to help raise their awareness about using AI tools and data sets critically. We also work with target groups that do not have a technical background. So we collaborate with the Cyprus Pedagogical Institute, which is the branch of the Ministry of Education that trains our public school teachers. And we also recently introduced a course here at the Open University, which is called Everyday AI, which we developed in the spirit of open and distance educations. These courses are obviously offered in Greek to enable a broad participation. And we use, hopefully, as you can tell from this, very simple everyday examples of smart technologies in order to help participants understand how they can analyze the behaviors of these technologies and to consider which aspects of intelligence are mimicked by them. One thing that we didn't actually really expect is how popular these courses would be. To be fully honest with you, the Everyday AI course was something that we did at the end of the SciCat project. Because of COVID, we hadn't had a lot of opportunities to engage the public, and so we offered this, we put it together and hoped that maybe 50 people would sign up for it, and we actually left the enrollment up to 400 participants, and it was fully booked. I think it's a great sign that there is interest and also dedication from the public in order to learn more about AI. So I'll end the talk with this slide, which shows a diagram from the 2019 Nature article by Ian Rao and colleagues. In their article, they advocate for a new interdisciplinary science of machine behavior, which draws both from engineering and computer science, as well as from the social sciences. And as we can see from the diagram, a motivation for developing this new science is that quantitative evidence describing machine behavior is needed in order to study the impact of technology on our lives. So what I hope that I conveyed in the talk is that an understanding of machine behavior, and to be more concrete, understanding the social biases inherent in computer vision applications like image taggers is just as much about understanding our own behaviors and biases as it is about understanding algorithms. I'd like to just acknowledge my team and thank them for everything. And of course, thank you all very much for your attention.